and space. There's 27 of these. And now I ask you to gamble on the next letter. So you could do it as a batch if you wish. How much do you put on Moby Dick, on Don Quixote, etc., but that's the hard way to do it. You have to imagine every work of literature ever written and ever to be written. So let's do it sequentially. And you guess here. Now, a guess corresponds to saying a letter like Q. Hey, it could be Q. Yeah. It could be Z. It could be probably not a B. So you'd say, oh, I think it's going to be Q, and the probability I assign to that is 1 in 20. So I bet 1/20th of my money on that. Okay, great. So that's what a guess is. Who wants to guess this letter, please? And then when we're done with this little game, we'll take a break. Who think you have a good guess? A. How much do you bet? You're going to have an exciting but short life. Okay. A. I'm going to limit you to 0.9 if you don't mind. 0.9 times 27. And this will give you some nice factor like 20. Okay. What do you think the next letter is? Someone else? I think you know what's happening. Have you seen this sentence? No. All right, what's the next letter? Y? How much do you how much do you bet on Y?
Even A. Seen A.
Oh yeah, A is correct. And your money is taking off fast. 50. Good. It's a Y. And now you have 27 times 0.5. By the way, if you were wrong, I would say you're wrong, and now you have half of your money left to array across the others. So that way I don't ask you to say, give me all 27 possibilities and their probabilities. I can ask you sequentially. It's the same thing. Okay, what's the next symbol? I gave it away, didn't I? Space? Yeah. Space, and you bet a lot on it, 0.9. Next letter's tough. So you might T. Yeah, T and I are good. Say that and say it. So indeed, you put your probabilities down and so on. Now, this is not to say that she was not a pleasant vocal performer. Talking about Jefferson, the Virginian, I guess maybe his spouse. So it's a tough one because vocal performer, you could see it was written 100 years ago. Right. But that was the sentence we're in the middle of. Okay, now we look at the amount of money we had, and we had a bunch of graduate students and a couple of professors gamble on 75 symbols of this text. It took them a couple of hours, and they made a certain amount of money. And how much money did they make? Well, 1 over 75 times the log of 75. Well, this turned out to be roughly 10 to the 75th dollars. So, if you have the null hypothesis that monkeys typed this manuscript, the likelihood ratio, I mean, the fact that you made 10 to the $75 instead of just $1, which is all you can get from the fair odds, is a likelihood ratio of 10 to the 75 to 1, you can reject the null hypothesis. The probability that this sequence occurred by chance alone, as judged by these human beings, is 10 to the minus 75. In any case, this turns out to be log 27 minus, if I put an expected value here, or if I believe in the Shannon-Macmillan-Bryman theorem and that this is an ergodic process, so I'll take the expected value off, h of script x. Of course, where 75 is an infinity, so on. But basically, you can see this is an estimate of the entropy of the text. And it turns out that when you do all this, you get an entropy is roughly, what, 1.5 bits per symbol. I think we put in 1.3. I think that's the text was simpler than most texts, so on. About 1.5. What would the entropy be if monkeys typed it? It'd be log of 27, which is roughly 4.5 bits per symbol. So we can cut 4.5 bits per symbol to 1.5 bits per symbol. That's a 3-to-1 compression by essentially gambling. Now, as I mentioned, there's a data compression scheme that's intimately associated with the gambling scheme. But at this point, let's take a 4-minute break, and then we'll start the next lecture. The next lecture will end at 1 o'clock.